I did that last year with Hallie. She was doing that one, and then they were like, well, here already does it. No, I didn't want to do it. I didn't want to do it yet. Well, I was just expecting to do it again. Yeah. I'm going to follow. I'm going to let it work. You know what? Okay, I told you that. Is it working or like pinch it? You know, like I do something. It's a bracelet, but it's a brace. I thought it was on there.
All righty. So let's go ahead and get out your homework. We'll get ready and check that.
I'm like so energized. I'm telling you.
I'll get ready and share my screen.
No, she said sit down. Oh, I just didn't want to because that's what Lee said. I looked, she said sit down. I thought she said sit down. Oh, well, I did the hard because that's what Lee did.
At first I didn't read the whole text.
I was freaking out. I was like, I never
I
did
didn't read the rest of it. I had to go on.
I caught my phone like, I can take that hard.
Remember that just a little bit. All righty, so let's go ahead and get out our homework. We'll get ready and check that. Sheets, notes. Well, I guess I didn't bring it. So let's see. On Thursday, we had worked on let's see. Okay, so our homework from Thursday, did we just have up a square root? Okay, so what we're going to do is, there we go. All right, so who remembers what the little symbol is called? Does anybody remember? I'll come over here. Anybody remember what our little symbol is called?
Index. Well, the number or the
Just the symbol. What do we call that?
radical?
The radical. Very good. So our symbol is called the radical. Okay, so that is going to be the part, and so when I explained it and I talked about the buddies, I did call it the house, didn't I? So the house that the buddies are in, we call that, that's the mathematical term is radical. My term is the house. But anyway, so that's the radical. Okay. Does anybody remember what the number underneath the radical is called?
Radicand?
And good. So the radicand, R-A-D-I-C-A-N-D. So we call that the radicand. And our book says that sometimes you'll see it called the argument. Always through Horizons, they'll call it the radicand. Okay. Now, part of it is the other part of it is going to be this little area right here. And we talked about when it's empty, when it's written, understand it to be what number? Does anybody remember what? We understand it to be a 2, that it would be a square root. Okay, so if it's not written there, we understand it to be a 2. But notice down here, there's a 3. The index is 3. So that just helps us. That's called our index. Okay, and the index tells us how many of each number we need to have to group it for one whole number to come out. Okay, so that's what helps us to know how many buddies we need to have. Okay, so let's go ahead and take a look at our answers for activities 5. Okay, let's see, this was here we go, from lesson 19. Okay. All right, so our first one, what did you list as your prime factorization for 45? What's our smallest prime factor of 45? 3, good. And so we had 3 times what? 3 times 5, good. So our prime factorization, we have 3 times 5. And so we can look at that because we have it. So if you break down 9, 9 is 3 times 3. So our index is 2. So that tells me I have to have 2 buddies. Okay. So I've got 2 3s. So that means my 3 can come out and my 5 has to stay under the radical sign. So my answer is 3 times the square root of 5. Okay. Let's look at 48. What did you find your prime your factorization for 48 to be?
2
Times what?
2
Times
2
times,
2
good, times
3
times, anything else? Nope, that's it. Okay, so we have 2 groups of 2s. So when those come out from under the radical, I know that I'm going to multiply those numbers. Okay, and then we can see that our 3 stays under the radical. So our answer here is going to be 4 times the square root of 3. Any questions on that one? Good. All right, the square root of 50. What is our smallest prime factor?
2
2 times what?
5
5 times.
5
Good, because 2 times 25 is 50. 5 times 5 is 25. So we pull out, we've got 2 5s, so our 5 can come out, and the 2 stays under the radical. Any questions on that one? All right, let's look at 52. Smallest prime factor?
2
2, okay. 2 times what? 2 times
3
3 times,
no,
nope. What?
it's 13
13, yeah, because it's going to be 52 divided by 2 is going to give me 26. 26 divided by 2 gives me 13. So I have my 2s, and my 13 stays under the radical. Okay, let's look at the next one. Now I have an index of 3, so I know when I buddy up, I have to have 3 of each number. So smallest prime factor is 2, and it's 2 times 12. So my smallest prime factor of 12 is 2, and that's 2 times 6. Smallest prime factor of 6 is 2, and that's 2 times 3. So now I have to have, oops, and I forgot to put my index right there. So now I have 3 2s. So that still comes out as one whole group. And then I have the cubed root of 3 underneath my radical. Okay,
So the main thing is like when we're doing square roots, we don't have to worry about having that 2 as our index. But when I'm dealing with cubed roots, or if you have more than, if it's a higher number than 3, you want to make sure that with your answer, you make sure to put that radical in that index in your sign.
All right, the cubed root of 40. 2 times 20. And so 20 is going to be 2 times 10, and 10 will be 2 times 5. All right, so I have 3 2's right there. So that group of 2's comes out, and I have the cubed root of 5 left. Any questions? Now the cubed root of 54, that will be 2 times 27. 27 is going to be 3 times 3 times 3. So now I have 3's that are able to come out, and the cubed root of 2. So I have 3 times the cubed root of 2. And then lastly, 56. I go ahead and I have an index of 3. And so I'm going to have 2 times 2 times 2 times 7, because we know 8 times 7 is 56. So 8 breaks down to 2, 2, 2, and then times 7. So here is our, we have a group of 2's that comes out. And then we have the cubed root of 7. Any questions on that column? Everybody feel pretty comfortable simplifying radicals? The first thing we do is break it into prime factors. The second thing we do is look at our index to determine how many we have to have in a grouping. And then we put our groups together, we pull out our whole number, and then whatever can't be paired up, or can't be buddied up, as I call it, has to stay under the radical. Okay? Well, let's go ahead and take a look at the other side. Now we are dealing with adding, subtracting, multiplying, and dividing. And so when I add and subtract, my index has to be the same for each problem, and my radicand, that number underneath the radical, has to be the same. So we can see I've got 3 times the square root of 5 plus 7 times the square root of 5. So we know that all we're going to do is add our first digit. So 3 plus 7 is 10. And then we just keep the radical the same. Okay, 12 minus 5 is 7. Keep the radical the same. Any questions on our addition or subtraction? Now when we multiply, we can go ahead and combine 7 times 3 under the radical. And since 7 and 3 are both prime factors, I know that I can't break that down anymore. So what I'm going to do is just simplify that and put it as 21 underneath the radical. Any questions on that? Okay, now on this one, I have a number in front of my radical, so I can go ahead and multiply 3 times 4 is 12. Then underneath my radical, I can do 8 times 12. Now, since I know that those are not prime factors, I need to go ahead and break those down to see if I can simplify that any. So I know 8 is going to be 2 times 2 times 2. And then 12 is going to be 2 times 6, and 6 will be 2 times 3. All right, so I've got everything broken into prime factorization. I'm going to go ahead and find my groupings. So I've got 2 buddies here and 2 buddies here, and then I have a 2 and a 3 left. So when each of these 2 groups comes out, I already have that 12. Now I've pulled out 2 groups of 2. Oh, let me see if I can, I'll write it a little bit closer this way. I already had the 12, then I'm pulling out 1 group of 2, 2 groups of 2, and then under my radical is going to be 2 times 3. So now I want to multiply everything together. So I have 12 times 2 is going to be 24, and 24 times 2 is 48. And then under my radical, I'm going to multiply 2 times 3 is 6. Everybody good with that? Okay. All right, now division. Same thing, I can go ahead and even though my indexes are the same, and that's the only requirement, my radicands do not have to be the same. So here I'm going to divide 12 divided by 3. 12 divided by 3 is 4. Then under my radical, I have 10 divided by 2. Okay, so I'm going to have 4 times the square root of 5. Everybody good with that? Any questions? All right. let's look at the next one. I have 90 divided by 3. So you remember we talked about how when I divide radicals, my indexes and my indexes have to be the same, okay? So I have got the square root of 90 divided by a whole number 3. So the first thing I need to do is I've got to turn that 3 into a radical. So what I have to do is think about, okay, what number is 3 the square root of? 9, good. So I'm going to make this the square root of 90 divided by the square root of 9, okay? I'm going to bring this down here because I had put all this for that problem. So then I can combine the square root of 90 divided by 9, and 90 divided by 9 is what? 10. So my answer will be the square root of 10. 10 is 5 times 2. Those are both prime, so I know that that's my answer. Everybody okay with that? So if I have a whole number and a radical, I have to turn my whole number into a radical and then divide. Excuse me. All right, indexes are the same. So I'm going to put them underneath the radical and have 32 divided by 4. And 32 divided by 4 is 8. Is 8 simplified, the square root of 8? It's not simplified, so I need to go ahead and simplify that. And that's going to be 2 times 2 times 2. We know that those are 2 groups, so it's going to be 2 times the square root of 2. So the main thing is anytime I get an answer, I want to check it and make sure that it is in simplified form, okay? So you'll get used to it, kind of going through the steps. I'm sorry, what, Hunter?
Square root or the cube root of 8.
Oh, was that one cubed root? It was, thank you, sorry. It was the cubed root of 8. See, that's what I get for forgetting my sign. So let me fix this real quick. So now, there, so my answer is 2, the whole number 2. There we go. There we go, because my index was 3. Thank you. All right, any questions? Okay, we always want to try to simplify as much as possible. Okay, so Hunter, did you get the email that I sent with the packet in it? Are you there, Hunter? We'll get him to. Okay, so what I'm going to do is I'm going to go ahead and pass out these packets real quick. And so as you can tell on our assignment sheets, okay, on our assignment sheets, it goes through and it shows us what all is included in each unit. Okay, so now we have got, you can see that we're at the end of our unit. And so we're going to be reviewing for our test that will go home on Thursday. So I'll go ahead and pass these out. Did you get this packet in your email, Hunter?
I'm not sure.
I emailed it just a little while ago. So if you don't have it, if you haven't printed it, it's fine.
Yeah, I'll print it.
All right, so go ahead and put your name on it. All right, so the copy machine is doing something weird. It's doing weird stuff. So Hunter, yours will be in order since I emailed it, but the copy machine at my TA from last period couldn't get it to work for some, and then he got a couple of back-to-backs, but then so some of them are back-to-back, some of them are not, and then some of them that are back-to-back, they'll go one way, but then you turn the page and it's upside down. So evidently it's either me having a Monday or the copier is having a Monday, or we both might be having a Monday. That might be part of it too. So anyway, so our copies may be a little messed up, but so I'm going to pull that up on here. Let me pull it in from my email real quick. Okay, and that was PreAlgebra.
It's printing.
Okay, cool. Great. All right, so this is a review packet that I put together to kind of help us practice through some of our skills. Now, the thing about the packet will be that there will be some pieces of it, some parts of it that we will do as assignments and as homework, and then the rest of it will be bonus, okay? So it'll help go toward bonus. That will go toward your test grade, okay? So the first section is dealing with squaring integers. And so we talked about when we're dealing with exponents, we talked about how if I have a number, that's called our base. And then when we have an exponent, that means how many times I'm going to multiply that base by itself. And when we use the word squaring, that means the number 2, okay? So a lot of times when we talk about a square root, that's why that understood index is 2, is because doing square roots, we learned, is the opposite of squaring a number, okay? So what we're going to do is we're going to look at these and notice that we have signs associated with our numbers also. So these are integers. Remember, integers are going to be positive and negative numbers. Think about the number line. And so we're going to be using these numbers, and we 5 squared. That means I have 5 times 5. And 5 times 5 is what? 25. Good. All right, let's look at the next one. I have negative 4 squared. So that means I have negative 4 times negative 4. And remember, if I have a negative times a negative, what kind of answer am I going to have? A positive answer. So negative 4 times negative 4 is going to be what? 16. Good. All right, 13 squared. I know I'm going to multiply 13 times 13. And has anybody memorized their 13s? No, that's not, it's not 13 times 2. Remember, it's 13 times 13. So think about it. 12 times 12 is, does anybody remember 12 times 12? 144. We know we're going to be dealing with a number bigger than 144. Do you know what it is, Hunter?
169.
169. Is that what you got, Olivia? 169. All right, the next one, I have negative 1 squared. So remember, that's going to be negative 1 times negative 1. And what's that going to be? Positive 1. Good. All right, 15 squared. 15 times 15. Does anybody know that one?
225.
225. Good. All right. So what we're going to do is we just went through these together. The middle column will be what we're calling homework.
The 1, is it negative 1 or?
So negative 1 times negative 1, a negative times the negative is positive, okay? And so then 1 times 1 is 1. So our middle column, we will put down as homework, and then the right-hand column will be bonus. Okay, so remember the bonus, it's up to you how many you do. You can do all or nothing, or some, whatever you want to do, okay? But for every, it'll be a quarter point for each item, so it'll take 4 correct items to get a whole bonus point. All righty, so that's that. Our next page is going to be order of operations, okay? So let's think through order of operations. Down the right-hand side, or the top of your paper, or the bottom of your paper, whatever. If you want to, you can go ahead and write MDIS So you can remember parentheses, exponents, multiplication, division, addition, and subtraction. Now, what do we have to remember if I have both multiplication and division in the same problem? What do I do first? I go from left to right. Same thing with addition and subtraction. If I have both in the same problem, I'm going to work it from left to right. All right. So let's go ahead and take a look at number 1. Number 1, I have 30 minus 3 in parentheses and then divided by 3. What am I going to do first? Parentheses. So I'm going to start with 30 minus 3. What is 30 minus 3? 27. And now I have 27 divided by 3, and 27 divided by 3 is 9. Very good. All right, let's look at number 3. 1 plus 7 squared. What am I going to do first? I'm going to do the exponents first. So I'm going to do 7 squared is 49. So now I have 1 plus 49, and that equals 50. Let's look at number 8. I'm sorry, number 5. That starts with an 8. Number 5 is 8 plus 6 times 9. What do I need to do first? Okay, I'm going to do that 6 times 9 first. So I'm going to keep my 8 plus, and what is 6 times 9? 54. So now I add 8 plus 54 is 60. Oh, 66, 62. I just heard you wrong. 62. All right, number 7. 7 plus 12 times 11. What am I going to do first? I'm going to multiply 12 times 11. So I have 7 plus, what is 12 times 11?
122.
All right. 12 times 12 is 144. 11 times 11 is 121. So 12 times 11, 122. And 7 plus 122?
129.
129. Number 9. 20 plus 16 minus 15. Yes?
12 times 11 is 132.
132. So then, what's our answer? 139. All right, we have addition and subtraction of the same problem. What do we need to do? Left to right. So I'm going to start with 20 plus 16, and that's going to be 36. And then 36 minus 15 is going to be what? 21. Good. Number 11. 9 times 3 plus 3 divided by 6. Parentheses first. So I've got to start with 3 plus 3. So I have 9 times 3 plus 3 is 6. And then 6 divided by 6. I have multiplication and division in the same problem. What do I need to do? Left to right. So that means I'm going to multiply first. 9 times 6 is 54, but then I divide 54 by 6, and what do I get? 9. Good. Okay, so order of operations. So let's move on to the next page and keep working on a couple of these that are a little more difficult. Let's look at number 13.
Wait, so is the rest of this page bonus?
We'll talk about what's going to be homework and what's going to be bonus when we finish. Okay, so let's look at number 13. I have 9 plus 6 divided by 8 minus 2. What do I need to do first? I need to do parentheses first. So I'm starting with that 8 minus 2. So I have 9 plus 6 divided by, and what is 8 minus 2? 6. All right, I have addition and then division. So what do I need to do first? Division first. So 6 divided by 6 is 1. So I have 9 plus 1 is 10. Okay. Let's look at 15. 6 plus 5 plus 8 times 4. Parentheses are going to be first. So I have 6 plus 5 plus 8 is 13 times 4. So now what do I need to do?
Multiplication.
I've got to do that multiplication first, and that's going to be 13 times 4. So I'm going to have 6 plus, and 13 times 4, we'll do 3 times 4 is 12, and then carry my 1, and that's going to give me 52. And so 6 plus 52 is going to equal 58. Good. Number 17. I have 9 times 2 is what?
18.
18 divided by, what's 2 plus 1?
3.
So we did both sets of parentheses all in one step, okay? Since we had 2 separate parentheses, we could go ahead and take care of them all in the same step. So now I have 18 divided by 3 equals 6. Good. Number 19, I have 7 times 7 minus 8 minus 2. What do I need to do first? Parentheses, 8 minus 2. So I have 7 times 7 minus, what is 8 minus 2? 6. Now I have multiplication and subtraction. So what am I going to do first? Multiplication. 7 times 7 is? 49 minus 6 equals 43. Good. And then for the in parentheses, I have 4 minus 1 plus 8 divided by 8 times 5. So where do I start? We're going to start in the parentheses, and inside the parentheses, I'm going to start with division. Okay, so inside parentheses, I have 4 minus 1 plus 8 divided by 8 is what? 1 times 5. Okay, inside parentheses, I have 4 minus 1 plus 1. How do I decide what to do first? Left to right. So 4 minus 1 is 3 plus 1 times 5. Staying inside parentheses, 3 plus 1, 4 times 5 equals 20. All right, and the last one on this side, 7 times 9 minus 7 minus 3 times 5. I have multiplication and subtraction. Where am I going to start? Multiplication, and I'm going to start with the multiplication on the left side, going left to right. So 7 times 9 is 63 minus 7 minus 3 times 5. Now what am I going to do? The application. 3 times 5. So 63 minus 7 minus, what is 3 times 5? 15. Now I have subtraction, so what order am I going to use? Left to right. 63 minus 7 is going to be what? $56. Okay. Minus 15. 56 minus 15 will be 41. Any questions about order of operations? Okay, so let's look back. And what we will do is we have got our evens that we still haven't done. So let's do numbers 2 through 16 evens will be our homework. And then 18 through 24 will be bonus. 2 through 16 evens will be homework. And then 18 through 24 will be bonus. And remember that if you know, with the bonus, you can do some, all, or none. So we've looked at squaring our numbers. We've looked at order of operations. The next thing we want to review is more exponents. But this time, instead of just squaring, I have any kind of exponent. Okay. So let's go down the A side. All right, so 1A, I have -8 squared. The biggest mistake I usually see when students are working with exponents is that they'll just multiply the base and the exponent, and they'll forget that this means I multiply the base a certain number of times, okay? One of the things I do want to show you, though, is one thing that's a little bit different. All right, so let's go ahead and work the first one, okay? So -8 squared means I'm going to have -8 times -8, and what's that going to equal? Positive or negative? Positive 64, because a negative times a negative is positive, okay? If I have two negatives when I'm multiplying, it's going to become positive. Now, one of the things I want to show you, though, that this textbook doesn't, is that when I am dealing with exponents, I have to pay attention to what's in parentheses and what's not in parentheses and look at my negative, okay? So the way that these two problems are different, in parentheses above it, I have -8 squared. But now I have -8 squared, but the way we read this is the opposite of 8 squared, okay? So if I have a negative and no parentheses, I'll look at this as the opposite of 8 squared. So the first thing I do is I look at what is 8 squared, and that's going to be 64. What's the opposite of 64? -64. So you want to pay close attention to, is my negative inside parentheses or is it not? And if it is not, then I know that I will have a negative answer. If my negative is inside parentheses and my exponent is even, then I know I'm going to end up with a positive. But let's take a look at this next one. Let's look at 2A. I have -6 to the first power. So this means I'm just going to have -6 times itself only one time. So that's going to be -6. So -6 to the first power. Anything to the first power is itself. Okay, so remember that if I have anything to the first power, it's just going to be whatever the number is. And since it is negative, it's going to stay negative. Look at -4 to the third power. This means I have -4 times -4 times -4. How many negatives do I have here? I have 3 negatives. And what did we learn about multiplying with positives and negatives? When I have an odd number of negatives, what kind of answer am I going to have? I'm going to have a negative answer, because a negative times a negative will give me a positive. But when I multiply a positive times this other negative, it's going to give me a negative answer, okay? So I know an odd number of negatives is a negative answer. An even number of negatives will be a positive answer. So 4 times 4 times 4. 4 times 4 is 16, and 16 times 4 is 64. So it'll be a -64. All right, let's look at 4A. I have 0 to the 11th power. How many times does that mean I'm multiplying 0?
11.
I'm multiplying it 11 times, but it doesn't matter if I'm multiplying it 1 time or 11 times. What's my answer always going to be? 0. Good. All right, so let's take a look at 100 to the 4th power. That means I have 100 times 100 times 100 times 100. Okay, that's a whole bunch of zeros right there, isn't it? So I know that 100 times 100 is what?
Is 11.
So let's take a look at it. I know 100 times 100 is going to be 10,000, because I have 1, 2, 3, 4 zeros. So then now I'm going to have 5, 6, 7, 8 zeros. So this is the same as 10,000 times 10,000. So that means I've got 1, 2, 3, 4, 5, 6, 7, 8 zeros. So then I come in and put my commas. So it's going to be 100 million. Bless you. All right. -2 to the first power is going to be what? -2. Anything to the first power is itself, and 0 to the 81 power, or 81st power. 80. What would? Yeah, it's going to be 0, I guess, to the 81st power. All right. So what is 0 to the 81st power?
0.
0. Oh, that 0 had a tail. Well, that one does too. Now. All right. 8A. 4 squared equals
16.
16. 4 times 4 is 16. 10 to the 5th power. Okay, so remember, how did we count our zeros earlier when we had 100 to the 4th power? We had 100 4 times. So now we're going to write 10 5 times. 1, 2, 3, 4, 5. So we're multiplying 10 times 10 times 10 times 10 times 10. So we've got 1, 2, 3, 4, 5 zeros. So I have my 1 and 1, 2, 3, 4, 5 zeros. Put my comma, so it's going to be 100,000. They like the 0 to the whatever power. 0 to the 43rd power equals 0. All righty, so let's take a look. Let's do 1 through 5 as homework, and then 6 through 10, and this is the B part. So 1B through 5B will be homework, 6B through 10B will be bonus.
Six B through what?
6B through 10B. Alrighty. Now the next section, it says factoring / distributive property. We've talked about it as the distributive property, and we've talked about how when I have a number outside of parentheses, that means I have to make sure to multiply it by each number inside parentheses. And in our book, we only dealt with whole numbers. We didn't have variables. In this worksheet, we're going to look at what happens when I have a variable, okay? Because we will be seeing this a little bit later, so we'll go ahead and start practicing it now. So whenever I have a number outside of parentheses, I have to make sure when I have a number with parentheses, what operation am I using? Multiplication. Okay, so right here, my parentheses are indicating that I need to multiply. It tells me I need to multiply. Okay, come on. Okay, but when I multiply, I have to multiply by each term inside parentheses. And the way I tell a difference in terms is they're going to be separated by pluses and minuses. Okay, so in this one, I have 2 terms inside parentheses, so I have to make sure to multiply 12 by the 5 and by the 12n. Okay, so what is 12 times 5? 60. Plus, when I multiply 12 times 12n, I'm just going to multiply 12 times 12. And what is 12 times 12? 144. And I'm going to leave the n on that. Okay, so we multiplied 12 times 12n. So I just multiply the 2 numbers together and leave the variable alone. Okay. Now, I have 60 plus 144n. These are unlike terms. These are not the same, so I can't do anything to combine them because 144 has a variable that it needs to multiply by if we knew what the variable is. Right now, we don't know what the variable is, so we can't do anything with it. So we would just leave it as 60 plus 144n. Okay? Let's look at the next one. 10 times 2 plus 7b. I'm going to multiply 10 times 2, and I'm going to multiply 10 times 7b. So what is 10 times 2? 20 plus 10 times 7? 70. So 10 times 7b will be 70v. All right, now the next one, I have a variable in both of them. I have 4 times 8t plus 4 times k. So what 4 times 8t, what's 4 times 8? 32. So I'm going to have 32t plus 4 times k will just be 4k. When I write a number in front of a variable like 4k, that indicates multiplication. Okay, so if I knew what k was, then I could plug that number in and multiply it by 4. But right now I don't know what it is. 4a, 9 times 9t plus 4. All right, that's our break. So we'll go ahead and take a 5-minute break. Yeah, what you need, bud?
Hey, can you see me, Jennifer?
I cannot.
Okay, sorry. It's Brantley. I'm gonna
Okay.
print it out for Hunter,
Uh-huh.
but he turned his screen off a minute ago.
Okay.
Because his device, his orthodontics device fell out. So
Oh
we've got,
no.
yeah, I know, again. So we've got to go to the orthodontist at 2:30. So he's gonna leave just a little bit early, okay?
Oh, that's fine. That'll be fine. Okay, yeah, because what we're doing primarily right now is just reviewing for our test that'll be on Thursday. So I will email the test on Thursday, and then we are going to start. Let's see, we will be working on lesson 20, equations with one variable. So what I'll do is I'll make sure to email you guys the lesson.
Okay.
And then that way, if y'all need to watch the very end of the video, you can, because I'll upload it in just a little bit. And so if y'all need to watch it, y'all can, or if y'all, you know, we may be pretty close to being, you know, done by the time he needs to leave or whatever. So, because I guess here the bell rings at 2:25. So anyway, but if he needs to leave a little bit early, that's fine.
Yeah, he's probably gonna need to leave by 2:15 at the latest.
Okay.
Okay. Thank you.
You are so welcome. Thank you.
He's back.
Oh. That was like remember that that was so fancy. With your black kitty cat bag. Black kitty cat bag. Or your black velvet bag. You still have that bag, don't you?
All righty. Okay, so we'll go ahead and get back to this problem. We had 9 times 9t plus 4. So the first thing we need to do is multiply 9 times 9t, and what's that going to equal? 81t. And then 9 times 4 is 36. Good. Keep on moving. 5a, I have 3 times 5 plus 6r. I multiply 3 times 5 and 3 times 6r. So what is my answer going to be on this one? 15 plus 18r. Good. Okay, go ahead and do 6a on your own, and then we'll check it. Okay, so 11 times 7u will be 77u plus 11 times n. When I don't have a number in front of a variable, I understand it to be a 1. So like 11 times 1 would just be 11, or you don't have to have any, you don't have to put that 1 there if you don't need to. So 77u plus 11n. All right, now they have 11 times 7 plus 3u. So 11 times 7, 11 times 3u, 77 plus 33u. All right, so that's the end of that page. So what we will do is we will have numbers 1 through 5b will be homework.
Sorry, what?
1 through 5b. And then 6 and 7 will be bonus. 1 through 5 of the B side will be homework. 6 and 7 will be bonus. All right. Now, dealing with negative exponents, okay? So back in lesson, let's see which lesson this was. I might have given y'all something that we haven't even done, have we?
Yeah, I don't.
Okay.
I don't.
So what we're going to do on this one is we're going to go ahead and do it for a minute, but it's not going to be on the test and you won't have homework on it, okay?
I'll see these guys.
Yeah, okay. So what we have when we have a negative exponent, all right? So I want you to think about something for a minute. Because we haven't even done reciprocals, have we? Okay. So think about if I have the number 2/3, what would I need to multiply that by to get 1? What fraction could I multiply 2/3 by to get to 1? I could multiply by 3/2 because 3 is what?
5. I mean 6.
6, and 6 divided by 6 is 1. We call this a reciprocal. Okay, so you know how when we divide fractions, how we have to keep the first fraction the same. We change from division to multiplication, and then we flip the last fraction. That means we take the reciprocal of the last fraction. And so I've had students there, I can't remember if it was my first year when I was teaching this or what, and they called it, somebody said something, they call it the refliprical, and it helps them to remember that it flips. Okay, so a reciprocal flips and changes places. So basically I can use the reciprocal of a number, and when I multiply that, it equals 1, and so it doesn't change the value of a number. Okay. So when I have negative exponents, I'm doing the same thing. So what I do is to make a negative positive. So think about, this is the same, 3 is the same as 3/1, right? So this would be like 3 to the negative 4th power over 1. So if I flip it, I would have 1 over 3 to the 4th, and my 4 becomes positive. So if I flip it, my exponent becomes positive. So what would I do to 2 to the negative 3rd power? What would that become? 1 over, or actually we'll go ahead and start it as if it was 2 over 1 to the negative 3rd. Then I'm just going to flip it, and my exponent becomes positive. This will just be kind of an introduction for you. You won't deal with this until Algebra 1, so I won't confuse you too much with it right now. So 10 to the negative 5th is the same as 10 to the negative 5th over 1. So if I were to flip it, it becomes 1 over 10 to the 5th. So what would 6 to the negative 2nd power end up being?
6 to the negative power over 1.
6 to the negative power over 1, and then I flip it, and it becomes 1
1
over
6
6 to the 2nd power. Okay, and then I can even go further from there and say, hey, well, 6 squared is 36, so that'll be 1 over 36. Okay, but we won't do that right now. So that's all we'll do on this page. Okay, we'll scoot on from that. Divisibility and factors. All right, so think about our divisibility rules. We know that any number is divisible by 2 if it is what kind of number? Even. Yeah, if it's an even number, I know it's going to be divisible by 2. Or if, you know, in the way if it's a big number, I know if the last number is an even number, then it's going to be divisible by 2. Okay? How do I know if anything is divisible by 3? I add the digits together. Okay, so let's take a look at number 5. 66 by 3. So the first thing I do is I say 6 plus 6 is
12.
12. Is 12 divisible by 3?
Yes.
Yeah. And so our directions here, it just says state if the first number is divisible by the second number. So all we have to do is yes. We don't even have to solve it. All we have to do is just tell, is it divisible? So go back to number 1. Is 60 divisible by 2?
Yes.
Yes, because 60 is an even number, so it's divisible by 2. All right, so that's 2 and 3. What was our rule for 5?
If it ends with a 5.
If it ends with a 5 or a 0. Let's see if we have any of those on here. They didn't give us any of those. Okay, how do I know if it's divisible by 6?
If it's divisible by 2 and 3.
It has to be divisible by both 2 and 3. So that means it has to be an even number. So 708, is it an even number?
Yes.
Yes, and now let's add the digits. 7 plus 0 plus 8 is going to be 15. Is 15 divisible by 3?
Yes.
Yeah, so it's divisible by 2, it's divisible by 3, so yes, it is divisible by 6. Good. What about by 9? How do we test if it's divisible by 9?
Well,
we add the digits again to see if it's divisible by 9. So 6 plus 8 plus 4. 6 plus 8 is?
Yeah.
6 and 8 is 14. And 14 plus 4 is? 18. Is 18 divisible by 9? Yes. So for 9 and 3, the rules are add them up, but for 3, add them up if it's divisible by 3. For 9, add them up and if that number is divisible by 9. And then what about 10? It has to end with a 0. So number 3, is that divisible by 10? No, because it's 92. It ends with a 2, not a 0. So let's look at number 9. Is that divisible by 2?
Yes.
Yes, because it is even. We did all of those. So I think that's all. That's all on this page. So let's go ahead and let's do 2 through 12 evens for homework. So 2 through 12 evens for homework. All righty, greatest common factor of whole numbers. Okay, so let's think about greatest common factor. What is the first thing I need to do when I'm going to look at the greatest common factor? What is my first step? What I'm going to do is I'm going to write some notes at the bottom of this page. So step 1, whoop. I need to list. I need to list, not list, let's not use list. Let's say find prime factorization for each number. Okay, so the first thing I have to do is I've got to do prime factorization for each number. Okay, so first step, prime factorization. Now, step 2 is going to be I have to circle common factors. And then step 3, then I multiply common factors if more than 1. If there's more than one common factor, I multiply them together. Okay, so first thing, I've got to do prime factorization. Second thing, I have to circle my common factors. Then whatever's in common, I multiply those together. Okay, so let's go ahead and take a look. I've got 33 and 22. Okay, so 33. What is my smallest prime factor of 33 going to be? 3. And 33 is going to be 3 times what? 11. And 11 is prime, isn't it? So that's all we've got to do. For 22, what is my smallest prime factor? 2. And that's 2 times 11. Okay, so remember when I'm identifying my common factors, I want to circle them together as a group. Okay? And then that way I can look at that and say the greatest common factor is 11. Remember, if I circle more than one group, then I multiply them together. I don't multiply 11 and 11 together, okay? So I've just circled them as a group to identify what that group is, all right? Any questions about that? Let's look at 30 and 20. What's my smallest prime factor of 30? 2, and what times 2 is 30? 2 times what is 30? 15. So now I need to break 15 into prime factors. What's my smallest prime factor of 15? 3 and 5. Okay, so 2 times 3 times 5 is going to give me 30. I can always check that to make sure that I did it right. And 2 times 3 is 6, and 6 times 5 is 30. Now I can look at 20. What's my smallest prime factor? 2. 2 times what is 20? 10. So now I need to break down 10, and 10 will be 2 times 5. All right, so let's see what we have in common here. I've got 2's in common, but then I have a 3 and a 2, but I've got 5's. So remember, if I have more than one, 2 times 5 is 10. So my greatest common factor is 10. Let's look at 27 and 33. What's my smallest prime factor of 27? 3. And that's going to be 3 times 9 is 27. So what's my smallest prime factor of 9? It's 3 times 3. Good. All right. And then 33, we know the smallest prime factor is going to be 3. And then we have 3 times 11. So what's the only thing that they both have in common? 1, 3. So the greatest common factor equals 3. Any questions about this? Everybody feel pretty good with greatest common factor? Let's look at 32 and 48. What is my smallest prime factor of 32? 2. And that's going to be 2 times 16. Okay, so now we have to break down 16. What's my smallest prime factor of 16? 2. And that's 2 times 8. Smallest prime factor of 8? 2. And that's 2 times 4. And what does 4 break down to? 2 times 2. Okay, so I've got a bunch of 2's there, so I always want to make sure that I didn't write too many 2's or that I wrote enough 2's. So I just want to check it. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. So I'm good there. Now for 48. Smallest prime factor, 2. And that's 2 times 24. Smallest prime factor of 24 is 2. And that's 2 times 12. Smallest prime factor of 12 is going to be 2 times 6. And 6 is 2 times 3. All right. So I want to make sure to group everything correct. So I have a pair of 2's, another pair of 2's, another pair of 2's, and another pair of 2's. And then I've got a 2 and a 3, so those are not in common. So I'm going to take each of these 2's, and I have 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So the greatest common factor is 16. Okay. So let's go ahead, and there's a whole bunch on this page that, and we're not gonna do a ton of them. Let's do for homework. Let's do 2, 4, 6, and 8 for homework. Okay, so 2, 4, 6, and 8 will be homework. And then any other ones that you want to do for bonus, you can. Okay. Notice down at the bottom, they just start comparing 3. Let's go ahead and look, let's do number 21 together for just a minute, just so you can see. So we'd have 12, 18, and 60. 12 is going to be 2 times 6. 6 will be 2 times 3. 18 will be 2 times 9, and 9 is 3 times 3. 60 will be 2 times 30. 30 is 2 times 15. 15 is 3 times 5. So remember, when I've got 3 numbers, I'm looking at what do they all 3 have in common. They all 3 had a 2. And then when I look here, I've got 3's in common. So 2 times 3 is 6. So the greatest common factor is 6. So the main thing is however many numbers you're having to find the common factor for, you just want to make sure that that same number is listed for all 3 numbers. If it's not listed for all 3, it's not a common factor. Okay, so like I said, 2, 4, 6, and 8 homework. All others will be bonus if you want to do them. And then I think last, nope, not quite last, we've got square roots. Second to last is least common multiple. Least common multiple and greatest common factor are similar in that you start the first with prime factors. So on this one, again, number one, prime factorization. Now what's different about this one though, is once we have our prime factors, we express them as exponents. Okay, so prime factorization in exponential form. Okay, prime factorization in exponential form. That means if I have more than 1 2, I list it as 2 to the whatever power. If I have more than 1 3, I list it as 3 to the whatever power. And then my step 2 in this one is I have to represent, or I have to place a box around the highest exponential value for each prime factor Okay, so even if it's a factor of only one number, I still have to include it for my least common multiple. Whereas with prime factorization, it had to be in all 3 of them. Now with least common multiple, it could just be a factor of one of them, but it has to go in. Okay, so that's the big difference. Greatest common value has to be common for all of them. Least common multiple only has to be in one of my factor listings. Okay, so let's look at 9 and 15. Okay, so 9 is 3 times 3, so I'm going to represent that as 3 squared. 15 is going to be 2 times 3. Okay, so what I've got to do, 2 times 3, what am I doing? That would not be correct. That would be 6. Sorry about that. I think I'm getting tired. 15 would be 3 times 5. Okay, so, and I don't have anything to list as exponents, so I'm just going to leave it as 3 times 5. Now what I've got to do is I've got to look at all of the factors listed. I've got 3s and I've got 5s. So I know I'm going to have to put a box around a 3 and around a 5. So what I have to look at is what is my highest exponential value of 3? 3 squared. What is my highest exponential value of 5? Just 5, right? Or 5 to the first power? Okay, so now I have 3 squared and 5. So now what I've got to do is for step 3 of this, I need to simplify, or I'll just go ahead and put multiply together. Multiply together. So the first thing I have to do is, so now I've got 3 squared times 5. What is 3 squared? 3 times 3 is 9, and 9 times 5 is 45. So the least common multiple of 9 and 15 is 45. We listed our prime factors first, then we represented them as exponents if we had any kind of repeating digits. Then we looked and said, hey, I've got 3s and I've got 5s. Remember, they don't have to both be in the same listings for both of them. So my highest exponent of 3 was 3 squared. My highest exponent of 5 was just 5. All right, let's look at 18 and 3. 18 is going to be 2 times 9, and 9 is 3 times 3. So I have 2 times 3 squared. And then 3 is just going to be 3 times 1, so my prime factor will be 3. So in this one, I have 2s and 3s. So I know I need to have my highest exponential value of 2, which is just going to be 2, and my highest exponential value of 3, which is 3 squared. So I'm going to have 3 squared times 2. So 3 squared is going to be 3 times 3, which is 9. And 9 times 2 is 18. So the least common multiple of 3 and 18 is 18. So remember the other way that we talked about that is it would be the same as saying, okay, 18 times 1, 18 times 2, 18 times 3, 18 times 4. You can list out your multiples, and then I would list out my multiples of 3, and the first one that I came into contact with that was in both of them would be, if I was listing out multiples of 18 and I listed out multiples of 3, the first number that I would come to that was the same for both is 18. Okay? Let's look at 9 and 21. We know 9 is 3 times 3, so that's going to be 3 squared. 21 is going to be 3 times 7, so I have factors of 3 and 7. Highest exponential value of 3 squared. Highest exponential value of 7 is 7, so I've got 3 squared times 7. 3 squared, we have seen multiple times over the last few examples, is 9, and 9 times 7 is?
Wait. 6.
Huh?
63.
63, good. So that's my least common multiple. Now let's look at 14 and 4. 14 is 2 times 7. 4 is 2 times 2, so we'll write that as 2 squared. So we have 2's and a 7. Highest exponential value of 7 is 7. Highest exponential value of 2 is 2 squared. So we have 2 squared times 7. 2 squared is the same as 2 times 2, and that will be 4. And 4 times 7 is?
28.
28. Good. And one more on this side, 7 and 6. All right, 7 is just 7, right? And then 6 is 2 times 3. I don't have any exponents, do I? And I've got all 3 different numbers. So that means I have to represent 2, 3, and 7. Okay? So I have 2 times 3 times 7. What's 2 times 3? 6. And 6 times 7 is? 42. Okay. All righty. So on these 2, 4, 6, 8, and 10, let's do 2, 4, and 6 for homework. 2, 4, 6 will be homework. And then 8 and 10 will be bonus. Now the last sheet, square roots. Again, our starting off point, just like least common multiple, just like greatest common factor, prime factorization. So step 1, list radicand as product of prime factors. And when I say product of, that means I'm just showing that they're being multiplied together. Okay, so we're going to list the prime factors as they're multiplied together to equal the radicand. Step 2 is I need to use that index to determine buddies. So I'll call them buddy groupings. So use the index to determine buddy groupings. I'll come over here and write 3 since my page is running out. And then number 3, my buddy groups come out as one whole and non-buddies stay under the radical. Oh, that's not gonna fit. Under radical. Come on, right. If I have more than one buddy group that comes out, I multiply those together. If I have more than one left under the radical, I multiply those together too. All right. I feel like we have been prime factoring the whole entire time, finding prime factors. All right, so we know that 100 is 10 times 10, and what times what makes 10? 2 times 5, right? So I know 100 will be 2 times 2 times 5 times 5. So I have 2s and I have 5s. My 2 and my 5 both get to come outside, and 2 times 5 is 10. So also knowing perfect squares, the square root of 100 is 10. All right, 256. Does anybody know if that's a perfect square?
Yes.
Okay, Hunter, what's the square root of 256?
16.
I'm sorry?
16.
16. Okay, let's try. What is 16 times 16? 6 times 6 is 36. And so got 16 times is 256. So we don't even have to do prime factorization on that. We know that that's going to be 16. Let's say perfect squares. Let's say that you had no clue that that was going to be 16. So what you're going to do is we're going to start out prime factorization. We know it's even, so I can divide by 2. So my smallest prime factor is 2. So 2 will go into 256. 256 divided by 2 is 128. 128 is even, so I know it's divisible by 2. So 128 divided by 2 is 64. Now 64 is even, so it's divisible by 2, and that's going to be 32. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4, and 4 divided by 2 is 2. I've got a whole bunch of 2's here. Okay, so what I want to do is I want to make sure that I don't have too many and make sure that I have enough. So 2 times 2 is 4. Do what?
I have to go now.
You have to go now? Okay. Have fun at the dentist. I know that it's kind of not not fun, but anyway. All right, we'll see you on Thursday. Okay, so we're looking and we have 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is 128, and 128 times 2 is 256. So I have the right number of 2's. Now we buddy them up. I have 2 2's, 2 2's, 2 2's, and 2 2's. All right, so that means I have this group of 2 comes out, this group of 2 comes out, this one comes out, and this one comes out. So 2 times 2 is 4, 2 times 2 is 4, and 4 times 4 is 16. So you have no clue the perfect squares. You can always list buddy it up. Whether you're able to buddy up, comes out as a whole number. If there's anything left under the radical, it stays. What's the square root of 25? 5. Good. What's the square root of 81?
9.
9. Good. Square root of 16?
4.
4. Square root of 4?
2.
2. Square root of 0? 0. Square root of 1? 1. 1 times 1 is 1. Let's see if we have any that are going to be left over. Nope, they're all going to be perfect squares. All right, so we'll do 1B, 2B, and 3B as homework, and we'll leave the rest of them as bonus. They're kind of big numbers. 1, 2, and 3. Homework, and then the rest is bonus. All right, I think that is it for the packet. So these are the skills that we will be having on our test, okay? Now, here's the deal. The test will go home on Thursday. All of this work is not due on Thursday, okay? This will be due with your test the following Monday, okay? So you've got a week to work on this packet, whether it's to do just the homework and no bonus work, or some bonus work, or all bonus work, however you want to do it, okay? This will be due with your test next Monday. Now, I do want to say, I know that there has been some challenges with uploading stuff to the homework site, and so if you have trouble uploading or whatever, if you need to take pictures and text it to me or email it to me, that is fine as well. It's totally up to you, okay? All right, so what I'll do though is I will send out a complete list of what all the work is. Probably you've written it on your paper, and so you've probably got it, but I'll make sure that we send a complete list just so everybody knows for sure what in the packet is homework and what is bonus. But what we're going to do now is we are going to go ahead and shift gears for a minute to a new section that will not be on the test, okay? So we are going to turn to we did lesson 19, so I think lesson 20, is that right?
Yeah.
So here. All right, so lesson 19 was being able to look at a written expression and write it as a mathematical expression. So now when we move on to lesson 20, we are going to be writing equations that have a variable, okay? And so we've talked about how a variable is a letter that represents an unknown number, okay? So a variable is going to be a letter that represents an unknown number. Let's flip back for just a minute to writing expressions with one variable. Why is that? Ooh, okay. Okay. So when we wrote these expressions, we just gave part of it, but we didn't say is equal to whatever. So now when I use the word equation over here in lesson 20, an equation means that I've got something on one side is equal to something on the other side. So anytime you see that equal sign in between, I know that this side is supposed to be equal to this side, okay? And so that's how we're able to work with equations, because if we know that they're supposed to be equal to each other, then as long as I keep them equal to each other, I can work it down and solve for whatever the variable is. So it says to write equations with a variable, we want to let x represent the unknown amount, okay? Apply the rules for translating words into a numeric expression and separate the equal parts with an equal sign, okay? So that's what's going to be different here, is that we're going to have that equal sign. Now it says using the following rule to determine, use the following rule to determine where to place the equal sign. So all of the words listed right here means equals. So if it says something is something, that means equals. If it says is, are, was, were, equals, yields, or gives are all going to be signs for, or going to give me a signal that that's going to be an equal sign. Now, we are actually going to solve equations with one variable. So to solve equations with one variable, combine the like terms, getting the variables on one side of the equal sign and the constants on the other side. Y'all remember what constants are? Remember, constants are just numbers by themselves, okay? So variables are letters. Constants are numbers by themselves. If I have a number and a variable together, I call that number a coefficient. So like if I have 3x, the number 3 I would call a coefficient because it's with the variable. But when if number 3 is by itself, I call it a constant. Okay, so when we're dealing with these, you may hear me talk about a constant, a coefficient, and a variable. And that's how you know what the difference of those are. Okay, so it says when like terms appear on both sides of the equal sign, perform the same operation to both sides to maintain an equal equation. So let's go ahead and look at the example they've given us. 3x plus 4 equals 2x plus 6. That's what we're starting with, okay? So they're saying if I know what x is, then I could plug it in and this side is going to equal this side, okay? So the first thing that we do is we want to move all of our variables. So I'm going to make a little note right here. Step 1, move variables to left side. So notice on the right side over here, I've got 2x. I want 2x to move to the left-hand side. But to move it, 2x is positive. So think about if I was going to move it, I need it to go away on one side. So what is 2x minus 2x? Or actually, let's think about this for a second. What is 2 minus 2? 0. So if I take 2 away from one side, it makes that one 0. But if I take it away on one side, I have to take it away on the other side. Okay? So what I have to do is I want to subtract 2x from both sides. Okay? So now when I subtract 2x, I've got 3x minus 2x is x. But over here, I have 2x minus 2x, so those cancel out because 2x minus 2x is 0. Okay? So I'm going to mark those out on that side. So over here, I've got now 3x plus 4. And over here, all I have left is x. Okay? Oh, I'm sorry. I didn't do my calculation here. 3x minus 2x. What is 3 minus 2? 1. And so this is 1x, which we can leave as just x. Okay? So then I have x plus 4 equals 6. So then I'm going to work, I want to get rid of that plus 4. Remember, to move it, I need to subtract it because I need to make it equal 0. So on this side, I end up subtracting 4 from this side, which means I have to subtract 4 from this side. Okay? I'm not a huge fan of the way they've done it right here in the book. I prefer to do it a little bit differently so it's a little more visual. So what I'm going to do is I'm going to come down here and write it a different way. Okay? So I'm going to start with 3x plus 4 equals 2x plus 6. And like I said, my first step is I want to move my variables from the left to the right, I mean from the right to the left. So when I look over on the right-hand side, I can see that I've got 2x on that side. Let me fix that so it doesn't get confusing. Okay? So I'm going to subtract 2x from both sides. Now I can see that 3x minus 2x a lot better. And I know that 3x minus 2x is x. I still have plus 4 up here. So on this side, I have x plus 4 equals 2x minus 2x cancels out. All I have left on this side is 6. Now I can see that with x, I have plus 4. I want x to be all by himself, so I need that positive 4 to move to the other side. The way I make that positive 4 move is to subtract it. But if I subtract it from the left, I have to subtract from the right. So now those cancel out. So all I have left on the left-hand side is x, and then 6 minus 4 is 2. okay? So I like to write it vertically, and I like to line everything up so I can see what is moving and what is canceling and what is left, okay? I'm not a fan of doing it from side to side like the book shows. To me, that's just super confusing, okay? So, but the first thing I always do is I want to move anytime I've got variables on two sides. I want to go ahead and move my variable, whatever, and it's my coefficient. It could be a variable by itself, or it could be a coefficient and a variable. But I want that to move to the left-hand side, because usually when you see an answer written, it's going to be x equals blah, blah, blah. You know, so it's just easier to go ahead and move it in the first place than when you solve, you already have x on your left-hand side. Okay, so this is what we're going to be continuing to work on Thursday. I just wanted to introduce it today so we can kind of have an idea. Let's go ahead and look at the classwork. We won't have any homework on this today. I want you to focus on getting ready for your test that'll go home on Thursday, okay? So your homework will be to start working on your packet, on any practice work that you have, and any bonus, and getting ready for your test, okay? But we've got a few minutes, so let's go ahead and go through this classwork. 5 more than a number is 14.
So are we turning anything in for Thursday?
There will be nothing to turn in on Thursday, no. First of all, what is my word here that means equals?
Oh, no.
Which
Is.
one? Good, is. So I'm going to go ahead and circle that. I'm going to put my equal sign above it. Now, on the left-hand side, I know that everything on the left-hand side will go in my problem on the left of the equal sign, and everything on the right hand will go on the right-hand side. So 5 more than a number. What do I know more than is telling me to do?
Oh, wait.
You can flip back if you need to.
Addition.
Addition. So I'm going to add, and we said that we can let number be x, and 5 is 5, and 14 is 14. So on this one, we have 5 plus x equals 14. So 5 more than a number is 14. Because addition is commutative, I could either put x plus 5 is 14 or 5 plus x is 14. Let's look at the next one. 3 less than a number equals 5. That one's pretty clear right there about equals. So I know there's my equal sign. 3 less than a number. Now with subtraction, my order does matter. So what comes first, the 3 or the number? 3 less than a number. So I have number minus 3. So we said that's 3 less than a subtraction and x. So we're going to have x minus 3 equals 5. The next one says a number, we know that's going to be our variable, increased by a factor of. Increased by a factor of. What operation was that one? Increased by a factor of.
Addition.
Close. Multiplication. Increased by a factor of. The key word there is factor, and I know that factors are numbers that multiply together. So I know that's going to be multiplication. Now this is, like I said, this is where it gets kind of confusing when I have x times x, or I have x times something and I'm using the times sign. So that's why I want to make sure that I'm using either a dot or parentheses or something like that. And then now my word for equals is yields 12. So a number increased by a factor of 4 yields 12. So what I'm going to do is I'm going to have 4x, because remember we said that I can write a number by a variable, and it means multiplication, equals 12. 4x equals 12. All right, so that is it for today. We will pick up here on Thursday. If y'all have any questions, be sure to let me know, and I hope y'all have a great afternoon.